Now we get to the big problems involving differential equations. In the calculus AB level, in many of the previous years, during the free response section of the exam, there's been what's known as a separable differential equation, which is given to the students and they are asked to solve it. All right. So what I want to talk with you about in this video is the steps that we need in order to solve a separable differential equation. And then the succeeding videos will show examples of how we go about doing this. Okay. So again, if you keep in mind with the AP exam, there's 6 free response questions, and each of those free response questions is worth 9 points. Right? When you're solving a differential equation, as you see with these steps right here, that section, whether it's part A, part B, part C, it's usually part C, that section tends to be worth 5 or 6 out of those 9 points. So there's a lot of points that you can earn, some rather easily, some a little more difficulty, when you're doing these separation of variables. Okay, so again, what we're talking about is a separable differential equation. So that means what we're dealing with is some kind of dy dx, and you can see this in your notes in the bottom of the page there. Dy dx is equal to some function of x times some function of y. So there's a product between the x term and the y term. So for example, if you had dy dx is equal to 3x times y, that's a separable differential equation because we're multiplying the x term, 3x, times the y term. All right. What's not a separable differential equation is if there was something like 3x plus y. That's still a differential equation, it's just not separable, and you would not be asked to solve something like this because you can't separate the variables. But speaking of separating the variables, that's our first step. Okay, so what we're trying to do here is just create a nice separation. We're going to place all of the y terms on the left side of the equation, including the dy, and we're going to place all of the x terms on the right side of the equation, and that includes the dx. All right, so we're going to get the y's on one side and the x's on the other side. All right, and the reason why we're going to do that is once we've separated the variables, now we can find a couple of antiderivatives. Okay, we can't antiderive this. Let me go back to the other one right here because we've got x's and y's on the same side. But once we separate them, then we can antiderive the y side with respect to y, and we can antiderive the x side with respect to x. So second step is to antiderive both sides. Now we know from our antiderivative past that when we're finding an antiderivative, we need an arbitrary constant. We need a plus c involved. So technically, there's going to be a plus c on both sides of the equation, the x side and the y side, when we take our two antiderivatives. But since both c's are unknown, if we combine them, we still don't know what that value is, and therefore we can kind of save ourselves that extra step, and we're just going to put a plus c on the x side only, and that plus c is considered to be the combination of y's arbitrary constant and x's arbitrary constant. So now that we've antiderived both sides and we have our plus c, the next step is actually going to be to figure out what c is, right? And we can determine what c is just like we did earlier in the year, where we take the initial condition that's given to us and we plug in those values for x and y. Once we've done that, we now have only one variable remaining, that's c, so we can solve for c. Right? We're going to take that c value, put it back into the function, and then last but not least, we have to solve this equation, this function, for y. We have to get y all by itself. So you're going to be using your algebra skills and your pre-calculus skills to help you figure out how to get y all by itself. And once you've done that, you have solved the differential equation, because ultimately, remember what it means to solve a differential equation. You're given a derivative and you want to find the original function. So that's what we're trying to do here. It's just that now we've got x and y on the same side, which wasn't what we were dealing with in the previous differential equations.